Today we will be learning about linked lists. So before starting with that, I would like to tell you some basics of arrays, so which will help you to understand linked lists better. So let's start. Basically, there are two types of arrays: a static array and dynamic arrays. So this is the representation of a static array. It is of fixed length, and the main thing which is associated with static array is it has static positions. For example, if you have decided that you have to put 8 elements in an array, you have to predefine the array with 8 elements, and you cannot add the ninth element to it without copying the whole array to a new position. So let me explain you this with a memory grid. So this is a memory grid, and suppose we have to insert we have made an array of 4 elements, and we have to insert those 4 elements. So this is the position 101, and similarly in continuous manner this is the position 104. So we have predefined an array of 4 spaces. So the elements which we will be assigning to that array would be stored in the continuous manner, for suppose like this. And if we have to add an extra element, so what we have to do in case of an static array is we have to copy all those 4 elements from there and consider 5 places now, and we have to make an array of 5 places and copy all those 4 elements with one extra space which we will be using to store our fifth element. So this is basically the static array. So its time complexity increases because we have to copy the whole array to add or append any extra element there. So we have to append 9, then we have to copy all the elements of the old array and paste them into a new position with one extra space. So this is what is static array. And now let us talk about dynamic arrays. So this is the representation of a dynamic array. So what we do in a dynamic array, let us understand with the same memory grid. So suppose we have this memory grid, and what a dynamic array is, if we have to store 2 elements in an array, so in dynamic array it will make more than 2 spaces. So let us see in this picture that we have stored only one element in the array, but it has one more extra space stored with it, so that in future if we want to add another element we can add it easily without copying the whole array like this. So but this array also has some corner cases, like in this case, if we have to add the third element, now we have to copy the first 2 elements to the new position, and it will also take some extra space with it, like of 2 boxes, and then the third element will be inserted and the fourth element can be inserted very easily. So 2 to the power n will be the number of extra boxes which, or the extra memory spaces which a dynamic array store with it. And so we have some corner cases, like this case is a corner case. If we have to insert a new element now, then we have to copy all the 4 elements to a new position, and the array will make some more extra spaces with it. So like this way a dynamic array works. So as we have seen that arrays all the time store the values in a contiguous memory allocations, or locate them into contiguous memory allocations like these. But in case of a linked list, let us understand it with the memory grid. If we have to store 4 elements in an array, then they would be stored in contiguous memory locations like this. So now in case of static or dynamic array, if we have to append another element in it, so the time complexity increases drastically because we have to copy all the elements. In case of static array, all the time we have to copy and paste, but in dynamic array there are some corner cases wherein we have to copy all the elements. So linked lists are far better than arrays. So let me now explain what is a linked list. So linked list is a collection of nodes. So these are the nodes in a linked list, and this is the first node is called the head node. The node consists of 2 parts. First is the data part and second is the address part. So a node consists of the data of the list and the address of the next node wherein the data of the second data is stored. So for example, if we have to store these 5 elements in a linked list, we can store our first element here. it has the address of the second element, it will point somewhere here, and then like this we can store our elements anywhere in the memory locations with their addresses. So they use more memory as this also store the address of the next node, uh, as in the case of arrays. So this is the basic and the major difference between an array and a linked list. So let us now jump to the coding part. So we will be using OOPS concept to design our linked list, and first and foremost thing that we want in a linked list are the nodes. So for designing nodes, we will make a class node, and in that class the first parameter will be self, the second will be the data of the node. So this is the data, and for us it is none till now, and then the second will be the next, or the pointer which is pointing to the next position. This is also none till now. So basically these will be the two things we would be needing from the user, and then self dot data equal to data, self dot next. So we would also be needing a second class for our linked list, and in that linked list we would be storing the position of that. So we will not be asking for the position of that from the user, because it will cause us it can cause us a problem, because the user can definitely sometime give the wrong head position, and then the linked list will start from that position and the previous values will be discarded. So we don't have to handle those previous values, because Python has its own garbage collector. So but the linked list will be destroyed, means it will be the wrong linked list we will be working on. So yeah, for now self.head is also none. So now in a linked list, now we have to make the methods to make a linked list. So first of all, the first method which we will be making is inserting at the beginning of a linked list. So insert any element at the beginning of the linked list. So make that method insert at beg. So inserting at the beginning, we will be asking for data from the user. Then after receiving the data, we will be making a new node from that data. So yes, so for making a node, we would be wanting the data which the user will give us, what we have to insert at the beginning, and the next element which we want in a node is, it will be pointing towards the current head of that linked list. If we want to insert something at the beginning, so the previous or the existing linked list, the first element will point to the head of that existing linked list. So that is why we have written self.head in the next, because the new node will be pointing towards self.head, and obviously we have to change the position of the self.head to the new node. So self.head equal to no. So yeah, this is for making or inserting an element in the beginning. So let us also make a method for printing. So basically I want to tell you that what is the basic difference in a method and a function is, when a function is has been written in a class, then it is called a method, and otherwise it is a normal function. So yes, for printing, all we need is, first we have to check the condition that if the linked list exists or not. So we will check it by if self.head is none. So if there is no head, then we will print linked list is empty, and we will return. So if self.head, if the head of the linked list does not exist, that means the linked list does not exist. So it will return linked list is empty. And now if the head exists, then we have to make a variable iterator, and then self dot head, we will point the iterator to the head of the linked list, and let us make uh, an empty string with which we will be representing our linked list. So while means while the value of the iterator is not empty or none, so llstr plus equal to string of self dot sorry dot data. So first I have to increase the value of the iterator. Then so yes. So what we have done here is we have taken an iterator from the starting of the linked list, then we have created an empty string llstr linked list string, and while iterator is none, while we are iterating through that linked list and we are finding elements in that linked list, so at that time what the data of the iterator, the pointer, will be stored in that string. And we can also use some good symbols to represent it. And then we will increase the value of the iterator, because iterator will become iterator dot next until we reach the last node. And then when we will reach the last node, when this while loop ends, then we will print the llstr. So yes, that is something. So let's try this code till now. So first we have to make a linked list object. We made the linked list object. Now let's call the method insert at beg 5. Now let us SERT, sorry, I've written the wrong spelling. Now let's try to print it out. So at this time the linked list will be empty, so we will be adding 5 to an empty linked list. So let's run it and try. So we have got our output 5. So let us try to insert another element. Then print it again. So in this way 21 is inserted at the beginning. So let us move to the next method which we have to make. So the next method which we will be making will be inserting at the end maybe. So def, so let us do it in a understandable manner. That insert at end, it will take self and data. So inserting any node at the end of the linked list would be pretty easy, because all you have to do is you have to change the pointer position of the current last element of the linked list to the new node, and the next position of the new node would be none, because it is the last node and we are inserting at the end. So first we will check if self dot head is none, if the linked list exists or not. If the self dot head is none, means the linked list is empty, so inserting at would be inserting the single element at the beginning only. So we will create a node with data and with none at the end, and return. For inserting at the end, we have to iterate through all the elements, so we will initiate our iterator while itr dot next. So we will have, while we have an element in front of an iterator or element at the next position of the iterator, we will continue the loop. And if we have to find the end element, then we have to put this condition, because after the end element itr dot next will be none, so the while loop will end. So in while loop we have also done the increment of the values. Then after reaching the end value, so this idea dot next is the end value of that existing linked list, and we have to point it to the new node we are making with data and none. So this is our insert at end method, so we can try it out very easily. I hope it will work. So ll dot insert at end 5. Let's run it. So it is running, and now what we have to do is insert at end 21, then print it again to show you where is the position of 21. It will be after. So we have got our position 5 and 21, 21 at the end. So this shows us everything about this method. So now what the next method we have to make, or we will be making, so now the next method we will be making will be insert values. So for inserting values, so if we provide a list, then we have to insert that whole list into the, or convert that whole list into a linked list. So we will be for inserting those values, the list we would be passing into the method. So we are checking, or we are making the self dot head equals to none, because we will be updating it later. So for data, iterating through that list in data list, self dot, we have made that method self dot insert at end data. So in this way we will be inserting the values at the end, and self dot head will be updated by the method insert at end. So let's try this. This was a very easy one. Insert at no insert values. What we have to pass is the list of elements. So let's try 1 2 3 4 5 6. Now let's just print it out. So we have got our answer. So this is inserting or making values. So now let's jump to the another method which we want to make, and which is very important, I guess, because this is the most important method. So this is the self.getLength method. It will be very useful in further methods also to get the length of the linked list. Let me make it length, and let's just think what we have to do for finding a length. So for finding the length of the linked list, the basic thing which we have to do is creating a variable, account variable, initiating its value to 0, and then iterating over the linked list and updating the value of the count variable till we find the last element and then returning that value again. So let's do it right now. As always, itr equal to self dot head, and while itr is not none, because we have to, so we have not written while itr dot next is none, uh, because we have to get the length of the linked list and we are initiating it from 0, so no need to write that. And then as 1, so yes, increasing the value of itr to itr dot next and simultaneously increasing the count, and then at the end return the count. So we can try this method at this point also. ll dot get length, ll dot print, oh okay, this is a major mistake. So it is returning count, so we have to print ll dot get length. This shall work now. Let's remove this and check it now. So yes, so we have got the length of the linked list, which is the 1 2 3 4 5 6. So yes, so let us now jump to another interesting method, which is remove at method. So remove at some position, so what we will need is self and the index for which we have to remove the element for. So, yes. So in this condition, first we have to check for the index if the given index is correct or not. So if index is less than 0 or index is greater than equal to self dot get, so this is where we are using get length, and we can use it in many ways. It is a very good method. So if this is the case, we will raise an exception invalid index, and if this is not the case and if we have to insert the value at the 0th index, then this is also a special case. We can do it directly and very easily because we are very familiar with these methods. So self dot head, so the thing which Python has in removing at index 0, which is very cool, is it has its own garbage collector. You don't have to dispose the value. So what we have done for removing at index 0 is we have just changed the position of the current head to the next element, and the previous head would be disposed automatically as we are using Python, and it has its own garbage collector. So if we were using any other language, we have to do that manually. So yes, so this is very easy. And now for any position other than first position and the invalid index, we just have to maintain the count, and as always point the iterator to the head, and then while itr if count. So what we will do is we will only go to the element previous to the element we have to remove. So in removing, what we have to do is we have to change the pointer position of the previous element of the index given to the next element of the index given. So listen it carefully again. We have to change the pointer of the previous element of the given index to the next element of the given index, so that the middle node is So we break the middle node and it will do the job for us. So index -1 itr dot next equal to itr dot next. So this line is changing or breaking that middle node. And then we will break and increase the position of the ITR after every condition or in every loop. So let us try removing anything or something. So let us make a linked list by ll dot insert values. Okay. Now ll dot remove at. So second, let us remove the value at second index and then ll dot print. So let us see if it works or not. The remove at method is not working correctly. So let me see if there is something wrong. Forgot to change or update the count value. So this is now this shall work. So yes, so the value 3 has been removed at the index 2. So this is how we can remove a value in a linked list. So now let us move to the next and the last method we will be doing in this video, and it is insert at. And now this will be pretty easy for you guys. We will be needing the index at which we have to insert and the data what we have to insert. Now again checking the same condition which we have checked in the previous thing, so we can now just copy and then paste the same condition for invalid index, and then again doing the same thing if index is 0. So we have to insert, and we can use insert at beginning if the index is 0. So self dot insert at beg the data which we have provided and then return. Now for the third case, similarly initialize the count, making the iterable variable, while loop till itr exists, and if count is index -1, we will create a new node, data, and that will, we have to insert that, then that will point to the next node or the succeeding node. Then change the itr value to the current node and then break. So we will not forget to change itr to itr dot next, and then the count value. So now yes, we can try it. Insert at, so instead of remove at, let's do it insert at second position only. We also have to give the data of the node, like 31, let's say. Now let's debug the file, run it again, and we have got 31 at the second position. So this is how, these are the major, what we say, like these are the major methods we can use with a linked list. And so you can do any kind of questions with these, and hope you learned this concept. And what I especially suggest you, so if you don't understand anything, you write it 2 times on your own computer, and you will get to know what these things are about, if I'm not wrong. So try it and let me learn. Thank you.